Hello, you are welcome to this channel, Research Plus. In this channel, I provide you with AI approaches to research analysis, interpretation, and reporting. If this is your first time of coming to this channel, please subscribe to this channel, and anytime I come up with new quality content video like this, you'll be the first person to be notified. Thank you. Let's take our today's class, and God bless you. So the first thing to do in order for us to run our analysis in SPSS is to move our research question from MS Word, where we've typed it, to the SPSS interface. So I'm going to divide my screen into two. I will show up all that I've typed on MS Word and the SPSS environment together. So what do I do? From the screen, the first thing you are seeing there is the interface for SPSS, and that is a data view. So I'm going to move it to variable view, as you can see. So I will now position my hands on window icon from the keyboard. I will use a directional arrow key to the right in order to minimize it to one side. Then come back to the MS Word and also put my hands on the window key and use directional arrow key to the left. This is how I have brought these two interfaces together in order for me to easily transfer my data from MS Word to SPSS to enable us run analysis. So from here, I am going to go down. Looking at my questionnaire, you will see that I have demographic data before the other instruments. So I am going to copy all this demographic data. I highlighted it. I press arrow key so that I can copy it at once. I highlighted all these ones. I highlighted it as you are seeing me doing. I highlighted this one. I also highlighted this. I highlighted this. Then I will press Ctrl C. I will now come to label. From this, I will click on it and right click using my keyboard, then paste. The moment I've done that, you discover that all the variables that were under my demographic data has been transferred to SPSS directly. So I am left with so for demographic data, I will code it as DI. I will code it as DI1 from here. DI1. DI1. I will come back to this one. DI2. I will come down to this one. Is DI3. 3. I will come down. Is DI4. I will come down. Is DI5. I will come to this one. Is DI6. And I will come down this one. Is DI7. So now I have coded my demographic data as DI1, DI2, DI3, DI4, DI5, and DI6 and 7. So I will now come to the value. I am going to define the value here. 2 decimal, I will take it to 0 decimal. But there is no penalty leaving it or changing it. So it is your choice to change it or to leave it. So as for me, I am changing it to 0 decimal. So I will now come to my value label. In my value label, this is where I'm going to define. Okay, in my questionnaire, I have gender, which is male or female. 1, I will now put 1 here is for for male, and I'll press enter, and 2 is for female. So this is how it is done, and I only have 2 options, so I will click enter. Automatically in my value label it has been defined. So I will now go to age range. In my age range, I have first option is 30 to 35, so I will give it 1 as 25 to 30 as 1. I will enter. I will now say 2 is from 31 to 35. I will now enter it. It's 31 to 35. This is 3. I have 41. I have 36 to 40. 40 as number 3. I have 41, which is number 4. I have 41 to 45. I will now press enter, and that is what I have. So I will now click OK. I'll click OK. I click OK. That is how you enter the remaining value of your demographic data, and you press OK. So by pressing OK, you will now discover that we have defined our value for the items that we have in our MS Word. We come to age range. It is an ordinal. When we come to marital status, it is a nominal scale. When we come to educational, it is ordinal scale. When we come to geographical, it is nominal. And when we come to language spoken, it is also nominal. And when we come to religion, it is nominal. From this point, you will discover that we have entered all our demographic data into SPSS environment with ease. So I am going to move forward. So like I have entered the other variable automatically, so also I'm going to do with my scale here. I'll now copy this item automatically by right clicking and drag. I will copy it, Ctrl C. I'll now come to my label column. I will paste, and you will discover that automatically my 5 liquor scale item here we are enter automatically. I will come to naming. Since I have code here, I will also highlight and copy the code and come back to this place. I will click and drag this place, and I'll also paste by pressing Ctrl V. So automatically you have seen that it has been entered in this place. So I will do for the rest of the items, and later come back to define it to put the value of all these items. So this is how I have done it, by adding all those variables from my MS Word environment to my SPSS. So you can now see it that every item of my liquor scale has been entered and duly defined. So the next thing I'm going to do is to enter the value for this liquor scale item. So let's go to where the value is. So we will now come to this place. This is a value tab. We come here and we click on this place. Then we now see that our item 1 on a liquor scale is strongly disagree. I will enter it. Number 2 is agree, disagree, and number 3 is undecided. Number 4 is agreed, and Number 4 is agreed. And number 5 is strongly agreed. Strongly agreed. So I will now add it and click OK. So you will now see what I'm going to do from this point is I'm going to copy this one, right click and copy. Then I will now highlight the rest of the item. I will right click again and paste. So you now discover that every of the information that I have as my Likert scale option is entered into SPSS. So having entered all my data to SPSS, from what you are seeing, I have entered all my data. I have defined the data as expected. 1, strongly disagreed. 2, disagreed. 3, undecided. 4, agreed. And 5 is strongly agreed. So after this, I'm not going to switch to data view. You will now see that the data view is empty. What it means is that by the time I collected my responses from the respondents, I will bring their numerical value to this place. You know that when we are running analysis in SPSS, we are dealing with numerical values. We are dealing with numbers. So those questions that have been sent to respondents to respond after they might have responded, we have encoded it, giving it numbers. So it is those numbers that we collected. We are going to impute the number into this place. So let me just add an example with this particular question, TS2. So in TS2, let's say someone pick 1 as strongly disagree. I will come back to this place and type 1. So by the time I switch to see the responses that this person has selected, you will discover that it means strongly disagree. So you will now see it from here. So I am going to extract the data from my respondents as they have responded, and I will enter the data here. So just like I said, that the next thing that I'm going to do is to copy my numerical value from where I've collected it from my respondents, and I have collected it in an Excel sheet. So you will now see that in an Excel sheet here, you will see all the numerical value that my respondent has given me. So what I've just done is to highlight it from here and copy the whole of this into my SPSS dashboard. So this I have done, and in this tutorial I have decided to increase the number of respondents to 260. So having done that, what will be the next thing that I am going to do is to check the reliability of my instrument. You cannot run analysis in SPSS without first check the reliability of the instruments, and later you can check the normality of your data. So these are two paramount things that you need to take into consideration as you were to do your data analysis using SPSS. So now we are ready to go. You can switch from the value level to see the responses in Word. Just as you have seen, I have clicked this. I can switch it to data view, and I can switch it to variable view within the data view. This is exactly what I have done. You will see all the responses according to their opinion. So the next thing that we are to do, just as I've said, let's go and check the reliability of my instrument. And let me say this thing before we move further. there are some researchers that will come up when they have, let's say they have 3, 4 constructs within a research studies. They will just come up with one value of reliability coefficients, let's say 0.7, and tell you that it is an overall reliability coefficient. I think that is a wrong way of finding reliability. The right way of finding the reliability is to find the reliability of each construct. So for this study, I use 5 Likert scale items for each of the construct. That is why you will see that I will have teacher 21, teacher 22, teacher 23, teacher 24, teacher 25. All these 5 is one construct. So I am going to merge these 3 constructs together, these 5 Likert scale items, in order for me to find the reliability coefficient of this construct. So let's sit down. As I don't want you to miss any of these steps. Don't fast forward. If you fast forward the video, you will miss exactly what I'm going to do. So the next procedure is to click on Analyze. You go to Scale and you are going to click Reliability Analysis. So in this reliability analysis, you are going to see that a dialog box will appear. And in this dialog box, a label has appeared. Label came up. So, and it looks confusing if I'm going to use label here. So the only thing, I will want it to display variable names, not variable label. So I will right click and select this one. Automatically, it has shown me all my coded variable names. And as I have told you from the previous lesson, that in running analysis, there are 2 major parts, which is the demographic and the other part of the main variable or our variable of interest. So I'm going to concentrate on those variables of interest, not demographic data. So what I'm going to do is that I'm going to move my first 5 construct, first 5 Likert scale items. I will click on it. I'll click Shift key. I'll click 2. I'll click 3. I will click 4, and I will click 5. So I'll now move it to this place. As I move it to this place, my interest is on crunch bar alpha reliability coefficient. So I'm not going to touch anything. I will now click on my crunch bar reliability coefficient. Mind you, at the course of this presentation, there is a table of decision making that we use. And in our table of decision making that we use, let's check whether this reliability coefficient is acceptable for us to work with it or not for us to work with it. So like I have said, that this table that I've shown from the previous lessons is a guiding benchmark for us to use in order to accept or reject our reliability coefficient. So from the summary, you will see what we call case processing summary. In this case processing summary, it gives us the total number of the populations that have involved in the study, and we have 260 respondents responded to the question. So we don't have any missing value, and we have a total of 260. That is not what we are interested on. What we are interested is on reliability statistic, which is the crunch bar alpha coefficients. So we have 5 items. I told you that we have 5 Likert scale items for one construct. So we've gotten a reliability coefficient of 0.663. So in SPSS, it doesn't show you the first 0. You'll see 0.663. It simply means 0.663. So in this one, let's come back to our decision table. We now says that a value that ranges between 0.6 to 0.7 is a questionable reliability coefficient. So by our measuring standard, we have a reliability coefficient that is questionable. So let's proceed to check for the reliability coefficients of others. So we will now proceed from this place. We will still just go to we will now go to analyze, and we'll still go back to scale. We go back to reliability coefficients. So we go back to each reliability coefficients. So from here, I will now click reset. I will still go back and say show label. So now I am going to use the next item, which is PS. So PS1, PS2, PS3, PS4, PS5. I will move it to this place and I will click OK. So let's check what will happen. Very good. It has worked it immediately and show us the coefficients. So let us look at this one. So for these ones, we have a crunch bar alpha coefficient of 0.869. So let's compare it with our benchmark decision table. So look at it. We now says any reliability coefficients that ranging between 0.8 to 9 is a very good reliability coefficient. Wow. So this one have made the condition of our reliability is a very good one. So from this, what does this actually mean? It means that the internal consistency of our instrument to test those information we want, those internal, those invisible facts about our construct, we'll be able to test through this one. So that is how we are going to do for the rest in order for us to check and work with it. So sit back as we continue this study. Don't miss any part. If you enjoy and you are getting value from this, give me a thumbs up to encourage me bring more videos that are available like this for new researchers and even older researchers now. So after we calculated the reliability of our instruments, we have to report the reliability coefficients in our report writing. So in each of the construct, you report the coefficients that is gotten for that particular construct. And if case deleted, if you delete a particular construct, a particular item within the construct, you have to report it and tell the reader of your research report that you have removed this item because it has not contributed to the reliability coefficients of that test. So there is no crime for removing it and reporting it like that. So the next thing we are going to do is that we have to transform our data in order for us to run a regression with it. So what we are going to do is that we are going to match all these Likert scale items so that we can have a one continuous variable. So how are we going to do that? The procedure to do this is very simple. You come to transform. Are you seeing it? You go to compute. So in this compute, we are going to give our target variable, which is the new variable we want to form. We will form a new variable within the construct. So the first construct is quality of trainer. So in this place where it is written target variable, I am going to use QT quality. I'm going to use quality of T. Quality of T. That is my target variable, a new variable name. So where it is a label, I am going to write the full name of that variable. So it is quality of trainer. So I will now click OK. So from this place, so just follow me gentle and see what I'm going to do. So I have entered the label, the full name of that construct. I will now come to, I will select all from functions groups. So I will now come down here. I am looking for mean. You know, from one of our tutorial class, we said mean in SPSS is a king. So I will click on mean. So by the time I click, or I will double click it, it will just appear here with question mark. So from here, I am going to compute, and I will now right click this one. You will now see the names of my variable appeared. So this question mark that you are seeing from here, I will click the question mark and begin to enter my variable. So what I'm going to do, I will double click QT1, I will put command, I will double click QT2, I will put command, I will double click Q23, I will put command, I will WQT4, I will put command, and I will WQT5. By the time I press OK, a new variable, it has shown error message. Something is wrong with my DC. I have not put QT5. So I will now click, I will put QT5, then I will now click OK. Automatically, you will now see that a new variable has been added to this, and it is a continuous variable. Look at it. It's called quality of T. So from this point, this is the average for each of my construct. It is the average. So this is what I'm going to do for the rest of the variable, so that we will, from this point, check the normality of our data, and we will decide to run a regression from this point. So just sit down, don't skip this video as we continue this analysis. So that is how you continue to enter the variable as you have seen me I have done now. So the last one I am putting now is performance. So I will now come to label it, and it is the same performance because it's a one word. So we don't have a problem here. Performance. So from here, I will now click continue. I will now come back to this place. I will position my cursor here. Delete this Likert scale item here. I will now come. We have PR1. Double click it. Put command. PR2. Double click it. Put command. PR3. Double click it. Put command. PR4, double click it, put command, and PR5, I will double click it, and I will click OK. Automatically, you will now see that a new 5 variable has been added here as quality of trainer, continual scale. We have post training, we have a participant engagement, resource material, delivery method, and performance. So any analysis I'm going to do in SPSS, I am going to concentrate on these 5 variables. So I don't have anything to do with this individual Likert scale again. So from this point, we are going to check the normality of our data, and after we check the normality of our data, we are going to run our regression, depending on what type of regression we are going to run. So this tutorial, we are going to do a multiple linear regression, because we have 5 independent variables imparting on one dependent variable, which is performance. But let's continue and see whether our data is normally distributed. I said that I am going to check the normality of the data before running the analysis. But because I don't want this video to be long, because if this video is long, you will get worried along the line, and you be patient to sit down in the class and see exactly what we're doing. So for this very reason, I'm going to use a combinations of instructions in order to carry out the check of normalities and the regression analysis simultaneously. So just with me and sit down and watch this aspect. This is the most sensitive aspect of this tutorial. So just sit down and watch. From this point, we are going to analyze. We'll click on analyze, and because we intend to run regression, we are going to click on regression, and we will go to linear, because we are going to use linear regression. So just you right click here and let it display variable names as we are saying. And from this place, our dependent variable is performance. So we'll move our performance to dependent variable, independent variable, and I will move them to this place, independent variable. From this place, I'm going to click on statistic, and here on statistic, I am going to check for descriptive statistic. I'm going to check collinearity diagnostics. I'm going to check Doomin, Watson, and I'm going to check case diagnosis. So, and the standard deviation is automatically put at 3. So, any other thing I'm going to show you as the result of this analysis is out. So, I will click on continue. Then I will now click on plug. So, on this plug, I'll move my dependent variable to Y, and I'll move this one to Z. So from here, I'll now click histogram, and I'll now click normality probability plug. So these two things, histogram is one of the conditions to check the normality of my data. So from here, I am going to click continue, and I'm going to click OK. Within a short time, you'll discover that the SPSS is running my analysis, and the analysis is out. So this is the analysis of my regression. So let's look at it. You will now see descriptive statistic. You see performance. You see the mean 3.9. You see quality of trainer. You will see post-training support. You see participant engagement, resource and material. You will see delivery method. All this, the mean value is shown, and the standard deviation and the end. But that is not what I am so much interested in this analysis. So you just look at it gradually. You just look at it gradually. You will now go down. You will now see a modern summary. You will see an ANOVA table. And I'm not going to explain anything here. I will start with the result. And where will I get the result? The result is coefficient table. This coefficient table is what we are going to use in order to judge our test of hypothesis. Our hypothesis is going to be tested using the result of the coefficient table. So you are now going to see that I have my t-value and I have my significance level. So you will now see 0.001 is significance, 0.444 is significance, 0.014 is significance, 0.8 is not significance, it's above the decision benchmark, and you will see delivering method is 0.000. So from this value, you will agree with me that most of my hypotheses will be positive, will be significant. So from this one, let's get down and check. We will check collinearity. You look at the value is significance. Let's go down and check the normality of our data. Very good. This is a probability curve. From the probability curve, you discover that my data is normally distributed, and you also see my PP plot regression standardized. You now see it that my PP plot is relevant. So by what I'm seeing here, it means that my data is normally distributed and I'm permitted to run a linear regression. So the next thing I am going to talk on the model summary. This model summary is it shows me is an explanatory power of the model. So what does it mean? Look at the R and the R square. The R square simply tells me that 45% of this model has explained the independent variable as respect to the impact it has on performance. 47.3%. This model will only explain 47.3% of those factors that can impact performance. So this is what the model summary is. While the ANOVA table explain how fit is this model to my to what I'm doing. So we will now see that it is significance. The value is showing significance, and the F value is 57.1. So by the standard of regression, you will all agree with me that my data is normally distributed, and my test of hypothesis based on the result I'm having here is a significance result. So I hope that in this place you have gotten value and you are not confused to this level. So from this point, the next thing we are going to do is to see how we are going to report this in our report writing, and that is going to come up in another tutorial class. So I want to appreciate you so much for taking your time to be with me in this tutorial. And if this is your first time of coming to this channel, I will plead with you that you should subscribe to this channel. You should give me thumbs up. You should like it. You should share it with your friends so that we can create a positive impact within the community of researchers. And at the end, I want to appreciate my provost, which is the Professor Danjuma Silas of Elelium Bible College and Seminary, Cairo, Nigeria. Thank you so much. Till we meet in our next class. Bye bye and God bless you. Variable